Good morning, thank you very much. And thank you to the organizer for inviting me to present our work on ocean noise mapping. The work I'm going to present today has been developed especially in the framework of the Marine Strategy Framework Directive. I will give some details, but before, so this is a user uptake funding. And I'd like to thank also my co-authors here, the people who are doing the real work, Robert Chavannes, Dominique Clorenec, Roger Gallou, Arnaud Levaufre, and Lancelot Six. Next. All right. Just a few words about Quiet Oceans. We are an SME based in Brest, in France, specialized in the issue of underwater acoustics, environmental underwater acoustics. So we provide services for the industry and for the governments on dealing with the issue of underwater noise. So we develop technical solutions to address the issue. So why do we care about underwater sound? Most of animals do use sound to communicate or they use a sonar to catch their prey and to communicate among them. That's true for the large whales, but that's also true for fish and for invertebrates. And so most of animals use sound. The sound they produce and they use is interfering with natural noise that has always existed in the ocean, like the wind, who is generating waves, and the waves breaking, they generate noise. But also lightnings or sediment movements do produce noise. On top of that, the humans are producing noise as well with their activities. There are a lot of activities generating noise, like shipping, oil and gas exploration, marine energy. So all this noise will interfere with the noise that the animals are producing, and the animals will be exposed to this noise, and sometimes when it's a very high levels, it can go to injury. So this is now regulated at the European level through the Marine Strategy Framework Directive. It's the 11th descriptor who deal with the introduction of energy in the marine environment, and the acoustic energy is included. This is to deal with the adverse effect of the marine life, and the way it has been recommended to deal with this is to use a combination between measurement, sound measurements in the ocean, and modeling. And that's exactly what we are developing. So why, well, the sound, here is an example of the same sound source, that's a vessel in Gibraltar. So on the left, the vessel in the Atlantic, and on the right it is in the Med. It's the same source, but because the temperature distribution and the salinity distribution is different, the spread in color here, the spread around the source is different, because the propagation of the sound is very much influenced by temperature and salinity. So that's why the products provided by CMEMS are key products for our services. We have to take temperature and salinity into account. We use temperature salinity. We also use waves, surface waves, because the surface waves generate noise, and we have a model that is able to map and to evaluate the noise generated by the waves. So we also take this data. We use real-time and delay time data and the global layer, but also regional data. So the system we have developed is bringing together a number of different data. The first type of data is the maritime data, which is describing where the sound sources are located. So that's mainly based on AES, but not only. We need to describe how the noise sources distributed on the surface of the ocean, how this sound is going to propagate in the ocean. So we need to know what the bathymetry is. We need to know what the sediment's nature is. So we have this in place. Then we need to describe the temperature and the salinity, which is changing with time and changing with space. And we also need to have some ground truth. So we need to have some sensors, acoustic sensors that will tell us at this location, at this time, this is what was measured to calibrate the model. So we linked all this data, we put that into an acoustic model, and we produced a noise map. So we do that for the governments in the framework of the MSFD, of course, but because it's regulated, the offshore industry is also concerned in assessing what the amount of noise they are going to add to the environment and how this is going to spread and what the risk associated to this. Managers of marine areas and researchers are also interested in these kind of products. So the system is worldwide, it's online, so you just need to connect to create an account and you can use it. We have a worldwide coverage, it's running 24/7, and it's meant to be a friendly interface because our customers, our users, are not familiar, are not experts in underwater acoustics. So we provide the expertise and we make their life as simple as possible. We have 3 types of modeling in place. We can do live modeling, which is going to be a near real-time mapping. Historical, which will provide a map of the statistical noise in the ocean, and predictive is where the user can add his own sound sources. If he has a project in the future, for example, he can add his own sound sources to predict what's going to be the noise he will produce in the future. So this is an example of a live modeling here in the area of Copenhagen, where you have one image every 15 minutes. So you can see a large variability of the distribution of the noise in the area just because the sound sources are moving because this is shipping noise. And you can also see the variability due to the oceanography and due to the bathymetry, where you have deeper places and very shallow places. In shallow places, the sound do not propagate. Where it's more deep, then it propagates better. Sorry, I think I'm going. Okay, so we are very linked to, and our service would not exist without temperature, salinity, and surface wave data. So we are very grateful about CMEMS to provide these products. Since the products are global and regional, we benefit from that. We also are able to do real time thanks to this, and that's it. So at the conclusion, underwater noise is a growing concern. It's now regulated in Europe, but not only in Europe, also in most of countries now. It's not only governments that are concerned, but also all the offshore industry. We have developed a solution, technical solution, that provides on-demand noise mapping, that provides near real-time mapping, but also statistical description at different scales, from day to months to year, at global, regional, and local scales. And we are using the CMEMS products for this. What is coming next now, because now we have a product that produces a noise map. Okay, so we know what the noise looks like. Now, what we need to do, and what the stakeholders want, is okay, what effect this noise is going to produce. So we need now to move forward to, based on the noise mapping we have produced, to derive all the risk for the marine fauna. And here I've put a scale of risks that can occur from injury if you are very close to the very high intensity sound sources, to masking, where masking is a more indirect effect, where the animal starts to have difficulties to communicate among the others or to catch prey. Thank you very much.